So now question 6. Determine or calculate the duration times in minutes in which a group of 100 people can be exposed to 1,500 ppm of carbon monoxide that result in 0% fatality. Okay, that's number 1. And number 2, that results to 50% fatality. So first, take a look at the probic equations here. Again, y equals to K1 plus K2 ln V. So let's take a look at what are these K1 value, K2 value, and V value for carbon monoxide. Yeah, we want to focus on carbon monoxide. So go to this table, look for carbon monoxide. And there you go, it's here. Okay, so V value, summations of C to the power of 1T, K1 value negative 37.98, K2 value 3.7. So let's translate all this data back to the formula. So we have y equals to negative 37.98 plus 3.7 ln CT. I don't need the summations here because since we're talking about single digit here. Yeah, so what we want to find out here is what is T. We want to find out T. So straightforward. So we want to next find out what is our y value. So A, when P percentage is at 0, what is y? Okay, so let's take a look back at this table 2.4. So you see, over here, if we are talking about 1% death, we are looking at the y value of 2.67. So in that case, we are assuming any value that is lesser than 2.67 is the value that we can use. So meaning in this case, if we want to talk about 0%, we look at 2.66, because when we look at 0, for example, then you can't do any calculation because there's anything between 0 to 2.66, the results will be 0% fatality. So we get the highest value. In this case will be 2.66. Yeah, so we put that back. So the y value here is 2.66 to do the calculation. So meaning this is the maximum duration that the people can be exposed to, T maximum, when P equals 0%. Okay, so simple. 2.66 equals to negative 37.98 plus 3.7 ln 1500T. Okay, same thing with our calculations just now. So you get something like 1500T equals to e to the power of what is that, 2.66 plus 37.98 divided by 3.7. Okay, so in that case you get something along the line of 5.87 times 10 to the power of 4. So if we put this down, T equals to 5.87 times 10 to the power of 4 divided by 1500, you get along the line of 39.1 minutes. Okay, so meaning maximum exposure in this case to result for 0% fatality is at 39.1 minutes. Means any exposures more than this, they might start to have people dying in that area. So the maximum exposure will be 39.1 minutes. That's for part A. So for part B, we are looking at P equals to 50%. Okay, so again, go back to this table. When P equals to 50%, so use a different color. P at 50%, our probability equations is at 5. So meaning Y equals to 5.0 from table 2.4. So again, put that back into the formulas, same formulas. So instead of 2.66, now you can 5.0 equals to negative 37.98 plus 3.7 ln 1500t. And so I think with that you can calculate what is t. So 1500 t is e to the power of 5 plus 37.98 divided by 3.7. So there you go when you do your calculations in terms of minutes. If I'm not mistaken, it is about 73.9 minutes. Okay, there you go. Solve the issues here. So meaning if let's say the exposure is up to nearly 74 minutes, we are expecting the estimated death rate for this exposure to this carbon monoxide at 1500 ppm will be around 50% death.